so this first problem wants us to find the area of a trapezoid. All right, so we have our trapezoid here. They give us all the information that we need. All right, all we have to do is use the formula for a trapezoid, which we do have. So area of a trapezoid is going to be 1/2 times the height, which they give us, in this case was 18. Remember, that's the perpendicular distance from one base to the other, times the sum of the two bases, right? So B1 plus B2, okay? So in order to find the area, we're just gonna simply plug into that equation based on all the information that we've been given, all right? So 1/2 times the height, which is 18. And then we're gonna add the bases together, so 27 plus 36. Okay, and then we're gonna go ahead and plug that into our calculator. So we're gonna obviously do the bases added together first. 27 plus 36 is 63 times 18, and then times 1/2. And our final answer should be 567 square millimeters. Okay, next up we have a triangle, and it says they want us to find the height of the triangle given that the area is 90 square feet. All right, so this time they're giving us the area and they want us to use that and this side of the triangle here to find our height, right, which is represented by h. So equation for triangle area, hopefully we know, is 1/2 the base times the height. Remember, the base can be any side, and then the height is the perpendicular distance from that base to the opposite vertex, all right, which is this dotted line here. So that's our height, which means that our base has a length of 6. All right, so let's go ahead and plug in for A and B, and then we'll just solve for H. Okay, so area is 90. That equals 1/2 times B, which in this case is 6, times H. All right, so now we're just doing a simple algebra problem to solve for H. We need to get this by itself. First thing we want to do is multiply these two together. So that's equal to 3. So 90 is equal to 3 times H, and then hopefully we know how to solve from there. We divide both sides by 3, so that means that our height is equal to 30. So in this problem we have a kite, right? And it tells us that the diagonals for the kite are equal to 12 and 5. And the problem says that that's the full length of each diagonal, so that way there was no confusion there. All right, so we need to find the area of a kite. We do have a formula for area of a kite, and that is 1/2 times the product of the two diagonals. All right, so this one's pretty simple. All we're gonna do is we're gonna multiply the two diagonals together and then divide by 2. So let's go ahead and plug that in. All right, first diagonal is 12. Second diagonal is 5. So 12 times 5 is 60. And then 60 times 1/2, our total area of our kite is equal to 30. Here we have a parallelogram, and it tells us that the area of this parallelogram is equal to 15. Okay? They give us the length of a segment that's perpendicular to the opposite sides. That's our height. All right? So that means that the height of this parallelogram is equal to 5. So the area of a parallelogram is just base times height. Okay, remember, base can be any side, but the height needs to be the perpendicular distance from that base to the opposite base. All right, so that means that these two sides need to be our bases. All right, so that's what we're solving for. So we're just going to plug that in. So the area is 15 and the height is 5. Then how do we solve for B? Well, we divide both sides by 5. And that means that the base of this parallelogram must be equal to 3. So this next problem probably caused a lot of frustration with most of you. That is because the correct answer was not one of the choices. All right, so I apologize for that. There was a typo on this question. Based on that, everybody will get it correct, and I'll adjust the scores accordingly. But let's go ahead and run through it so that way you can see if you were doing it correct, and I'll show you what the correct answer should have been. So we've got a regular pentagon, 5-sided figure, all the sides are the same. We want to find the area. They gave us the length of the segment from one of the vertex to the center, that was 6. Area of a polygon is 1/2 apothem, which is this segment here, which is from the center perpendicular to the side, times the perimeter, which is all the sides added together. So we just need to find the length of one side, and then we can multiply it by 5 since it's a regular pentagon. All right, so let's start off with the apothem. We need to find the length of that. All right, first thing we're going to do is we're going to find this angle here. All right, and that's going to be half of one of the central angles. All right, so first things first, let's find a central angle. It's a 5-sided figure. We know that all the central angles have to add up to 360. So we're going to take 360 and divide it by how many central angles there are. And since it's a 5-sided figure, there's 5 central angles. All right, so that's going to equal 72 degrees. That's our central angle. And so that is this angle here, the big one. And so we want to cut that in half for this little angle. So we'll divide that by 2. So that means that this angle is equal to 36. Okay. So there's our triangle. So let's expand it out here so that way it's a little bit easier to see. All right. So the 6 is going to represent our hypotenuse. All right. And then our apothem is going to be this side over here. So there's our right triangle. And then we've got a 36-degree angle there. All right, so let's use our trig functions in order to find this missing side. So this is the adjacent side. It's next to the angle that we've got. 6 is our hypotenuse, so adjacent and hypotenuse, we're going to use cosine. So that means that the cosine of our angle, 36 degrees, has to equal the adjacent side divided by the hypotenuse. All right, so we're going to solve for A, multiply both sides by 6. So our apothem is going to equal 6 times the cosine of 36. Okay, so there's our apothem. I'm just going to leave it like that for now, and we'll put it all in our calculator at the end. All right, this side, all right, is going to represent this segment right here. We'll call that B. All right, that's going to be half the length of one of these sides. So if we can find this side of the triangle, double it, that'll give us a side length, and then multiply it by how many sides there are, and that will tell us the perimeter. So let's go ahead and solve for that. This side is now the opposite side from our angle, so this time we're going to use sine. So that means that the sine of 36 has to equal the opposite side divided by the hypotenuse. Once again, multiply both sides by 6. All right, so that means that that side, B, is equal to 6 times the sine of 36. Okay? So there's those sides there. Now, to find perimeter, we're going to take B, we're going to double it to find the length of one side, and then multiply that by 5. So ultimately, we're going to multiply B by 10, and that will give us the perimeter, since there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sections there. All right, so perimeter is going to equal B, all right, which is this 6 times sine of 36 times 10. Okay, so let's write that all out in our equation up here. So the area equals 1/2 times A, which is 6 times the cosine of 36, times perimeter, which is 10 times B, which is that. So we've got 10 times 6 times the sine of 36 degrees. Okay, almost ran out of board space there, but we'll work with it. So now I'm just gonna put all this into my calculator all at once. It's all being multiplied, so it doesn't really matter which order you do it in. So let's go through and punch that in. All right, so let's start off with the cosine of 36. So we're gonna do 36 cosine times 6 times 1/2 times 10 times 6 times the sine of 36 equals, and there is our final answer. Now we can round it off. So the area is going to be equal to approximately 85.6. Okay, so if you got that, great job. Either way, everybody got it right. And once again, I apologize for the typo. Let's move on. So here we have a regular octagon. All right, this one's a little less complicated to find the area because they actually give us all the information that we need. So once again, area of a regular polygon is 1/2 the apothem times the perimeter. All right, well, the problem gave us the length of one of the sides. That was equal to 15. So in order to find the perimeter, we're going to do 15 times how many sides there are. That's going to be 8 sides. So that means that the perimeter is going to be 15 times 8, which is equal to 120. All right, so there's our perimeter. They gave us the apothem, so we just needed to be able to recognize the apothem there as the length of the segment from the center perpendicular to one of the sides. So that's 18.1. So let's just plug it into our calculator and it'll spit out an answer. So 1/2 times 18.1 times the perimeter, which in this case is 120. So 120 times 18.1 times 1/2, and we should have got a final answer of 1086. All right, so moving on to composite figures. All right, so here's the diagram that they gave us on this problem, and it wants to know the area of the entire composite figure. All right, so we're gonna break this up into 2 segments. We've got a rectangle here, and then here we've got a trapezoid, okay? So let's find the area of those 2. So let's first start out with the area of the rectangle. That one's pretty easy. It's just length times width. So we'll call that A1. So 8 times 6. So length times width, which is going to be equal to 48. Okay, not rocket science on that one. All right, second one's a trapezoid. We'll call that A2. All right, area of a trapezoid, remember, is 1/2 the height times the sum of the bases. So B1 plus B2. All right, now we need to figure out what those are. So if this is a rectangle, if that side is 8, then that means that this side is also 8. So that's one of our bases. They give us the other one, which is 16. Okay, so there's our 2 base lengths. And then we need the height, remember, is the perpendicular distance. Well, they tell us that this is a right angle. So the length of this side of the trapezoid, that will also be our height because it's perpendicular to both bases. All right, it says from here to here is 6. The whole thing is 12, so that means that this portion must also be 6. All right, so 6 is going to be our height. And then we're going to multiply that times 1/2. All right, so then in our calculator, we'll do 8 plus 16. That gives us, of course, 24 times 6 times 1/2. And that gives us a total area of 72. All right, now we just need to add those 2 together and that'll give us the total area. So we're gonna do 72 plus our original area 1 of 48. So our total area is going to be equal to 120. On this problem, we have another composite figure, but this time we're only finding the area of the shaded region. So we do not want to include this circular piece that's in the middle. So we only want the blue shaded region here. So we've got a circle that's cut out of a rectangular shaped piece that has dimensions of 40 by 10. All right. So in order to find the area, we're going to find the area of the entire rectangle, and then we're going to subtract this time the area of the circle that we do not want to include. All right. So let's go through and do that. First, find the area of the whole rectangle. All right. That is pretty easy. So the area of the whole rectangle is going to equal length times width, or 40 times 10, which is equal to 400. So there's the entire rectangle. Now we want to find the area of the circle. Okay. We'll do that in red. That's the part that we want to subtract out. Okay, so the area of the circle, they tell us this side is 10. Well, obviously the circle has a diameter which is the same as the width of this rectangle. So if the diameter is 10, that means my radius is 5. So we know area of a circle is pi r squared. All right, so that means it's going to be 5 squared times pi, all right, or 25 pi. So there's the area of the circle. I'm going to leave the pi in there for now so we can get a more accurate answer at the end. So now we're going to subtract the area of the rectangle and the area of the circle, and that'll leave us with what's left. Okay, so let's go ahead and do that now. So area is going to be 400 minus 25 pi. So let's go ahead and put that into our calculator. So we've got 400 minus 25 times, use the pi key, equals, and then that will give us a total area of 321.5 if we round it to 1 decimal place. One more composite figure here. All right, we did one similar to this on the practice worksheet last week. All right, so what we have is basically a square with a triangular piece missing. All right, so if we continue this on, extend it down, and form up that triangle that's missing there, we're going to find the area of the entire square, which is just length times width, and then we're going to subtract the area of this triangle, and that will give us what's left in the blue part. Okay, so first things first, let's find the area of the entire square. All right, so that's going to be equal 25 times 25, or 25 squared, which is 625. All right, so that's the area of the entire thing, including the triangle. Now let's find the area of the triangle. Well, it says that this side is 25, which means this other whole side has to be 25. So if that's 10, then what's missing is going to be equal to 15. All right, down here, this side also has to be 25. That one is 5. So that means that this side has to be equal to 20. So there is our base and our height for our triangle. So remember, area of a triangle is 1/2 base times height. So 1/2, 20 times 15. All right, as that's going to give us an area, 1/2 times 20 is 10. 10 times 15 is 150. All right, so then we're going to subtract those two. So we're going to do, to find the total area of our blue section, we're going to simply do 625 minus 150, and that should give us an area of 475. So that was our final answer.